In this case, we are going to consider a typical exam revision, which is actually a lot of things that we need to look into as we are preparing ourselves for the exams which are ahead of time. So we have got the General Education Certificate, which is our GEC. It is for our preparation, guys. So here we are going to consider a lot of things. Like I said, a lot of questions according to our syllabus. So we are going to use the 2024 exam to prepare for what we are going to have in our exams for this year. So the importance here is for you to understand how questions are given. How are you supposed to attempt the typical questions? All right. So we shall try by all means to explain as much as we can, because there's a lot of things, like I said. So if you are an individual, you can actually work out to a certain time, then you can leave out, then you come back, you continue from there, and so on and so on, because it's gonna be a lot of things to be explained. So you need to understand. So because of time, you can pause, you can come back again, watch uh, to finish up from where you left. So this was our paper one, which we are going to consider, which was out of 75, 2 hours, excluding the 15 minutes reading time. All right. So that is it, guys. So this test consists of 23 pages, excluding the cover page. So here I just set them separately, the questions. So for the question paper, you can be able to download this question paper if you check the pinned comment, all right? The pinned comment like this, all right? So there is going to be a comment which is pinned. That one, you can look for that one on the comment section. Then you download the question paper, or even on the description of the video that you're watching, you can check there so that you can be able to download the question paper. So at least you can be working with the question paper and also looking into the solutions. So there we are given, we are supposed to read the instructions and questions carefully. Answer all the questions that we are given. Okay? So we are given that in section A, do your calculations before, take note, do your calculations before choosing the correct option. We must do the calculation. Then we choose the correct option after doing the calculations. Okay, that is an instruction that you're given there. Then in section B, show all necessary what calculations. You must show all the necessary calculations up to the final answer. All right, then we are given non-programmable scientific calculators may be used unless stated otherwise, stated. That is, diagrams are not necessarily drawn to scale. All lines are regarded as what? As straight lines unless stated otherwise. So once you see a line, it is regarded what? As a straight line, unless it is something else. So the section A, it was having a lot of questions, as we do understand. And for the basic part of our revision, we are going to work out each and every question of the question paper that we are having. So that was our section A. Question number 1. Which number is undefined? Which number is undefined? So we do understand that numbers that we refer to as undefined, it is cannot be simplified. Cannot be simplified. So we are looking for, from the numbers that we are given, the one that cannot be simplified, such as a number where a constant is being divided by what? A zero. A constant over zero. That cannot be defined. That's undefined. So in our case, we can see that the correct answer was going to be on D. Without wasting our time, we can simplify the cube root of 8, which is -3. The square root of 8. Yes, we cannot simplify this one direct, but it is a value that can be obtained, the square root of 8. We can obtain this, which is 2,8. It's only that I fixed my calculator. Let's go back to the normal mode, which is, as you can see, it can be simplified, 2,8, 2, and so on. We can simplify this. 0 divided by 8, that's a 0. We can simplify this from our calculator. That's 0 over what? Over 8. This can be simplified, which is what? Which is a 0. But if we look into the last one, 8 over 0 like this cannot be simplified. So that is what we are having without wasting our time. So that is it on question number 2. Given these numbers, what is the HCF of the numbers, the highest common factor? Because we are given a condition where the calculations are needed before opting for the correct option that you're given, we are supposed to work out product of prime factors of the given numbers. In actual sense, we could have just looked into, like, you just look into the answers there. You see, okay, this one, you test the numbers, what you refer to as a factor. Remember, if we are to divide 125 divided by that number, 200 divided by that number, 510 divided by that number, we are supposed to obtain exact values. So we can test from these numbers. But because of what? The calculation concept that we're given on our instruction now. Our instruction there. In section A, do your calculations before choosing the correct option. So let's do the calculations there. Like I said, we are going to need the prime factors of the given numbers. The first one, 125, as a product of what? Its prime factors. So there is a 5 at the end, so we can try to work out with 3. Then we can see 3 is not fine, is not a factor. Then we move on to 5, all right? So there we can use 5. 125 divided by 5 is 25. Okay, we can use 5 here. 25 divided by 5 is what? Is 5. Then we can also use a 5. 5 divided by 5, which is what? Which is 1. Moving on to 200, we can use 2 here. 200 divided by 2, that is 100 divided by 2, which is 50 divided by 2, that is 25. So as you can see, guys, it is the same 25 that we are having here. So we're going to have the same thing. 5, that's a 5. 5 here, that's a 1. Okay, that is just a repetition. All right, 510. 510, we do the same thing. Okay, there is a 0 at the end, so definitely we can try 2 there, the smallest number. 510 divided by 2, that was 255. Guys, you can even use your calculator here. 2, that's 510. 510 there, divided by what? By 2, which is what? 255. So 255, because there is a 5 at the end, we can try 3 before 5. Okay, we can try 3. So let's try 3 here. Divide by what? By 3. So as you can see, you're going to have a whole number. So we are going to use 3. 255 divided by 3, that is 85. There is a 5 at the end, so we can try 3 before we try a 5. But because of this 8 that we are having, there's no need. We're going to use what? A 5 in this case. So 85 divided by 5, that was 17. By 17, because 17 here is a prime number, so there is no need of looking for another number, guys. It's already a prime number. Remember, we are expressing these numbers as product of their prime factors, prime numbers. So the HCF, it is a number that is common throughout. By just looking into these numbers, we can see that 2 is not common. We do not have 2 here. So 2 is totally out. We do not have 2 on these numbers. There is only 5, 5, 5 here. So we're just going to look into 5. We have a 5 here. We have a 5 here. We have a 5 here. So that is our highest common factor. We do not have any other 5. If we check it, there's a 17 that we do not have here, that we do not have here. If we are to look into the 5, there's a 5 here, yes, there's a 5 here, but here we do not have another 5. There is only one that we have. So we can just look into the numbers direct as they are. Then we can see, okay, 5 is our highest common factor. Because this is for 1 mark, guys. But anyways, if you do not understand this, then you have to rewrite these numbers as product of their prime factors properly. 125 is the same as 5 times 5 times 5, which is 5 to the exponent of 3. Then moving on to 200, that is 2 times 2 times 2, which is 3 times 2 to the exponent of 3. And then the 5 is 2 times, so it's 5 squared. Okay, then we've got the 510, which is 2. It is only 1 here, so that's 2. 3, it's only 1. Then 5, it's only 1. The 17 is only 1 again. All right, so these are the numbers that we are given. Remembering that the highest common factor is common throughout. But if you write your numbers as product of their prime factors in exponential form in terms of these exponents, you are supposed to look for the number that has got the least or the smallest exponent, remember. For the highest common factor, you oppose smallest exponent. It must be common. That's the first thing. The number has to be common. So looking into the first number, guys, there is only a 5 here. We do not have a 2, we do not have a 3, we do not have a 17. So meaning to say we are going to look into that 5. Into that 5. It is common, as we can see, throughout. So which one has got the smallest exponent of these? It is what? 5 to the exponent of 1. Remember that concept, we talked about it, guys. So therefore, we can say our highest common factor is 5 to the exponent of 1, which is what? Which is 5. So that is what we are going to have there. All right, so let's consider the other question, which is question number 3. The LCM this time, the lowest common multiple. Again, we can even test, guys. For the numbers that we are given, just test which one. Test 1800 divided by this, divided by this, divided by this. Are we going to obtain exact values? 30 is already out. 75 is already out, because if you say 1800 divide by 75, guys. All right? So it's the LCM. So the number here, 75 over 1800. As you can see, it's going to be a decimal. The same as a 30 there. So we are left with these two numbers, 1800 and 3600. So if we are to divide 3600 by each, it was going to be exact values, but it is bigger than 1800. It must be a multiple, but what? Being the lowest, the smallest. So it is 1800. If we divide here, we're going to get an exact value, exact value, exact value. So you can even test, because it's multiple choice, guys. But for the sake of the calculations now, how can we determine exactly this? We try, we write our numbers as product of their prime factors, just like the previous case that we had here. All right, so the smallest number there was going to be 3. 75 divided by 3, which is what? 25. So guys, we saw the 25 before. That was 5 into 5, then 5, which is 1 here. We move on to 450. We do the same thing. The smaller number, that's 2 here, which was going to be 450 divided by 2. 225 by 3. This one divide by 3, that was going to give us 75, divide by 3, 75 divide by 3, which is 25. Then we can choose a 5 there. So 25 divided by 5, that's a 5. 5 into 5, that's a 1. So we are done with 450. We do the same thing on 1800. So that is it, guys. For exam purpose, just need to simplify each if you cannot tell from the answers that you're given, and also for the sake of what? Simplification. So doing the same thing, divide here, that was going to give us 900. Then by 2 again, that's 450. Divide by 2, that was going to give us, guys, as you can see, this is 450 here. So it is the same thing that we're going to have for 450 going down. So that was going to be 225. That's a 3, which is 75. Then we said a 3, which is 25. A 5 here, which is 5. A 5, that's a 1. Okay. So from this part here, it is a repetition of this part as we had this one before. It was actually just a repetition. Even here for the 75, as you can see, guys, it was okay. I did not notice it, but it was just a repetition there. So from the given numbers, the LCM this time, it is not about being common, how the numbers, like, is the number common or not. It is about any number that is given there. As long you can see that number, it must be part of your answer. But we must consider now to say, if I have a 3, then there is also a condition where there's another 3 there. And there is another part where there's a 3. When it is like that, remember, you must consider the one that has got the highest power or the highest exponent. Okay, so that is it for the LCM. So 75 being 3 to the exponent of 1, 5 to the exponent of 2, 450 being 2 to the exponent of 1 times 3 to the exponent of 2, 5 to the exponent of 2. Then we have got 1800 as 2 to the exponent of 3. 2 to the exponent of 3. 3 to the exponent of what? Of 2. That's 3 to the exponent of 2. Then 5 to the exponent of 2. This is what we had. So from what we are given, we can say, like I said, it is not about being common of the number. It is just as the number is given, but you must consider where there is the highest common, the highest exponent there, or the highest power. All right, so our LCM, therefore, looking into the numbers, there is a 2 here. There is also a 2 here. Which one has the highest exponent? So that's exponent of what? Of 3. So we need this one, 2 to the exponent of 3. All right, then we move on to another number, which is 3. There is a 3, there is a 3, there is a 3. Which one has got the highest exponent? So the highest exponent here is what? Is 2. There's a 2 here, there's a 2. So you just take once, guys. You do not repeat these. So that's 3 to the exponent of 2. Okay, there's a 5 also, same exponent on a 5. So like I said, when the exponent is the same and being the highest exponent, you do not repeat the given numbers. You just take the single part, all right? So that's 5 to the exponent of 2. So this is your LCM. Guys, at least at this stage, you can simply use your calculator. Yes, you can simplify. This is 8, this is 9, this is 25, which was going to give you 1800. Or you could have simplified direct on your calculator here, 2 to the exponent of 3. So you can put this exponent, all right? That's 3. Then you move aside 3 to the exponent of 2. So it's a product here. 3 to the exponent of 2. Then there is a 5 to the exponent of 2. All right. So as you can see, this is 1,800. So the best answer is supposed to be what? On A, which is 1,800. So according to the working calculations, yeah, that is what you're going to go through, guys, in order for you to obtain the LCM. But like I said, it is something that we could have just looked into the given values. Then we can say, okay, this is our LCM. Given question number 4, what is the relationship of average speed to time in the table that we are given here? What is the relationship? So when they're asking for the relationship, remember there are two that you are supposed to expect in terms of direct or indirect proportion when you're given a table like this, right? The issue of a rate, guys, when you consider the rate or those ratios, they won't give us in form of a table the way that it is like right now. So the best is to consider the direct proportion and indirect proportion when given a table like this. So when we talk about an indirect proportion inverse, what is the condition or what are the conditions? Okay, remember, guys, I talked about this on our introduction. Where there is an indirect proportion, the constant k is supposed to be obtained from the product of the two variables that you're given. So in this case, if it was x and this is y, it was going to be xy, the product of x and y. Okay? Indirect proportion, you multiply. So here's time and average speed. So you can just say our time is t, our average speed is s. So if this is truly a condition of an indirect proportion, meaning to say we're talking about the product of t to s, time to average speed, which is ts. Okay? Then direct, because those are the two that we are supposed to test. It must be as a result of a division of the two. The time to the average speed, the time to the average throughout. It must be your constant. So it's supposed to be t over s, or we can use s over t. It can be this one to this one, this one to this one. All right. So let's test and see. All right. So if we are to divide, guys, here, let's test this one, the last section of our division, 12 over 60 or 60 over 12, and see 12 over 60. That is what? 1 over 5. Then let's do it here, 9 over 80. 9 over 80 like this. As we can see, it is not 1 over 5. It is not what we are supposed to what we obtained before. So if we do the same thing, we are not going to obtain the same answer for a division. So meaning to say direct proportion is out. In indirect proportion, the product of these two is supposed to be a constant. Is that so? All right, 12 and 60. Let's multiply. That's 12 times 60, which is going to give us 720. All right, 9 and 80. We do the same thing there. 9 times 80. Okay, 720 again. 8 and what? And 90. As you can see, guys, it was going to be the same. 8 times 90, which is 720. You do the same thing on 6 and what? 6 and 120, which is the same answer. So for the product of the two, we are obtaining the same thing. That's our constant throughout. 720, 720 throughout. So that's an indirect proportion, what we are given there. So it is a condition where also we could have considered to say what is happening in terms of the two, the time and the speed. Another way, as we can see, as the time is decreasing, these values of time, they're decreasing. 12, 9, 8, as we are going that side. It's decreasing. That's a decrease in terms of the values. What is happening in terms of the speed as we are going this same direction? So 60, 80, 90, these values, they are increasing. There is an increase. These two, they do not go hand in hand. So that's an indirect proportion. Remember that. From our introduction, I talked about this condition. All right. So anyways, guys, that is it. So the best answer there, indirect proportion, which was on C. All right. Let us consider another part of our question, which is question number 5. We are given that Tutor runs so that's 6 kilometers in 24 minutes. How long will it take him to run 10 kilometers at a constant speed? So if we are to consider this condition, guys, of the guy that you're given here, this is where we can use that condition of a rate testing to say for 6 kilometers, the time corresponding is 24 minutes. So how long? We're talking about the time there. To run 10 kilometers is still the same. Kilometers, we're talking about the same thing, distance. Distance to the time. So the same thing, 10 kilometers in terms of the time at a constant speed, meaning to say the speed is not changing. There's no change in speed. Same, constant. So what is going to happen? Imagine you are running at a constant speed. So where you covered the lesser distance, it means the lesser time. The more distance, the more time that we must expect. Must be more. So it is a condition, guys, where it is less. It is considering to the less value, the more to the more. In that condition, you treat it as a direct proportion, just like what we had before. What I was explaining, when they are the same, more to more, less to less. Not to say there is a decrease, on the other end, there is an increase. In this case, once we increase, it is also the time is also increasing. It is different from a condition where, let's say, we are talking about the number of men working in the same field. The more number of men, the lesser time they take. Here, at a constant speed, the more distance you cover, the more time you take. So that's direct. All right. So if it is direct, remember, that is where we perform what? Cross multiplication. So I'm going to multiply 6 to x. So that's 6x. Then 10 to what? To 24. All right. So that is it. If it is a condition which opposes indirect, you take along, you multiply along. Remember the concept, guys. Okay. So that is it. We need x, which is the time in minutes as we are given here. So we're going to find our x in minutes. All right. So that is our x. So multiplying 10 to 24, that was going to be 240 over 6, which is 40 minutes. But as we can see, our answers are not given in minutes, they're given in hours. So meaning to say there is a need of conversion here to hours. In an hour, how many minutes? It's 60 minutes, remember. So what about for 40 minutes, guys? Simply divide by what? By 60. That's for an hour. For an hour. Simply divide by what? By 60. So that was going to give us what? 2 over 3. Okay, which is on what? On C. So the best answer there was going to be C. All right. So according to the calculations, guys, that is what you're going to have. There are so many ways. There are so many ways. Remember, they also said at a constant speed. So you can even calculate that speed here. You calculate the speed. Speed is equal to what? Distance over time, but your time, you have to be in hours. You must convert to the hours. Then you take that speed because the speed is constant. All right, let me just do that one. Let me just do it for the sake of revision. So many ways. If you do not want to apply this condition of care, this is more or this is less, because they told you at a constant what? At a constant speed. So ask yourself, what is that speed? Because it is constant, so what is that speed? Where I can obtain it, it is here, where I'm given full information, where I have distance and what? Distance and time. So from our DST, we have got, we need what? Speed. So we need speed. So speed is going to be distance over time. Speed, distance over time. But our time has to be in hours, all right? So 24 minutes to hours. This one, 2 hours, that's over 60. 24 over 60. Let me use a calculator here. 24 over 60. Okay, that's 2 over 5. So this is 2 over 5 hours. Okay, that is our time in what? In hours. So speed is distance in kilometers, 6 over the time in hours. So this is kilometers per hour. Our time in hours. So we are going to obtain our speed kilometers per hour. So it's going to be kilometers per hour. Take note of the units. If you use the minutes, it was going to be kilometers per minute. So you must know what you're working with. All right, so let's divide 6 divided by this. What are we going to have? 6 divided by what? Let me open the bracket here for 2 over what? 2 over 5. So this is it. It was going to give us 15. So the constant speed they are referring to, it is 15 kilometers per hour. If it is 15 kilometers per hour, the question now is how long? We are now talking about the time given the distance and that constant speed. How do I calculate time now? That is our question. Time is distance over what? Distance over speed. Our distance is there, which is what? 10 kilometers. So that's 10 in kilometers over the speed in kilometers per hour, which is 15. So our answers our answer is going to be in hours. That is our condition. That is our condition. So 10 over 15. 10 over what? Over 15, which was going to give us 2 over 3, as we are given there, 2 over 3 hours. So, guys, answering these questions, they will be in your hands, these questions. All right? They'll be in your hands. We choose which way. So many ways of attempting them. All right. Then we are given a certain guy bought shares for what? For 5,300 at the beginning of March 2006. Then she sold the shares at the end of February 2023 and received 11,291.45. What was the compound interest per annum? Compound from our compound interest formula. From our compound interest formula, amount is equal to P into 1 plus I to the exponent of n. So the question is, what is, from the information, remember she bought 5,300 shares. That is like an investment principal. 5,300 money you start with. Okay? Then after some time, because it was done in the beginning of March 2006. So it's March 2006 to the end. We talk about March 2007, 2008, up to what? The end of February. Just the end of February. We are just entering March. So it's a complete year to be considered there. So this is going to give us the number of years. Simply subtract, guys, the difference between. So our n was going to be 2023 minus 2006. All right, which was going to give us 17. So that's our n, which is 17 years. All right, then the amount which was considered as received, what you received at the end of the period, it is what? We received this. So that is our accumulated amount, which is 11,291. All right, actually, guys, I was just supposed to substitute direct into the formula for the sake of time. Anyways, let's see. Our amount, 291.45 is equal to P, which is our principal of 5,300. Open the bracket, 1 plus I to the exponent of 17. So this is what we get. So in this case, it is to solve. Solve for what? For I. What was the compound interest rate? So we must solve for I. And as we can see, it's a percentage there. So on your calculations also, guys, consider to say your answers already given as a percentage. So multiply by 100 at the end. All right. So what can we do? There is an exponent. There is also the 5,300 here, which is a product. So let's get rid of that. It's a product. So how do we get rid? Simply divide. Divide by 5,300 both sides of your equation so that this can what? This can cancel. We are left with this bracket raised to the exponent of 17. For the sake of time, guys, how can we get rid of that exponent 17 there? Exponent. If let's say x squared is equal to 4, you introduce the square root. What about if it is x to the exponent of 3? Were you going to notice that the number that is on the exponent is the one that you're going to put inside of the root side? We cannot properly see this on a square root. Say there's a 2. So yeah, there is a 2 that is there inside. It's only that you do not show it on your calculations, but that is the concept. Then exponent is the one that you put into the root sign. So our exponent is 17. So we're going to introduce as the 17th root of this. Then we do the same thing here. 17 inside the root. So this neutralizes our exponent or cancels this exponent. So we are left with 1 plus I there. 1 plus I there is equal to this. The 17th root of what? 11291,45. Everything over 5,300. So in this case, guys, we need to find the value of I. So I can simply take the 1 to the other side, all right? So we saw that there is a 1 here. So we are going to take it to the other side. We subtract it there. It is what? I that we are having at the end. But simplifying this will give us a decimal. Will give us a decimal. To have a percentage as presented there, what am I supposed to do? I'm supposed to multiply everything by 100%. Whatever that you are going to get here, multiply it by what? 100%. This is for the sake of obtaining exact values. So here we do not simplify it, just leave it like that, so that we obtain exact values as we are given, guys. Look at the answers. We are given 4,3, 4,4, 4,5, 4,1. So any slight rounding off of answers can give you another answer which is wrong. So you must avoid simplification unless you are going to store your values in the calculator, unless you are going to store them inside of your calculator. But for the sake of simplification, so that you obtain exact values, do not simplify. Simplify at the final point. Okay, so how do I simplify? This is my calculator. So I'm going to open the bracket. All right, we need the 17th root. So that's going to have shift on this x to the exponent. Press it. It's going to give us the option where we can put the 17 inside like this. Okay, then we put a fraction. Let's insert our values. 11291 comma 45, everything over what? 5,300. So this is it. Then move aside again, then subtract 1, close that bracket. It was the one that we opened before, so we must close it at the end, then multiply by what? By 100%. So that was going to give us 4,5 to one decimal place. You can even shift, then set up fix or number 6, then press 1 to give us one decimal place. So that's 4,5. Okay, as a percentage, as we are given there. So 4,5, that was on A. So the best answer there was supposed to be what? Was supposed to be A. All right, then number 7, let's consider question number 7. On this question, we are given a product. Okay, that's a product. Then from that product, we are asked that which of the following expressions is an example of what? Commutative property. Remember, the commutative property is a condition where the product of A and B is the same as the product of B times A, where changing order of factors, changing this order of factors, changing them does not affect the product. As long as it's a product, changing them does not affect. So if it is 2 times negative 3, if I write starting with -3 like this times 2, one and the same thing. Commutative property. It's a multiplication that we are given here. So definitely, we are going to look into the multiplication. So A is totally out. It's an addition that we are seeing there. So A is totally out. All right. There on this one, there is a subtraction in this bracket. So this makes one to be out. That's C. All right. Let's leave this one. Let's move on to D. D is totally out. Addition. There is a subtraction here. We are talking about multiplication, guys. Let's look into C. Minus A times E. We just changed the order of these two. Minus A times E. All right, then let's move on. B times minus G. B times minus. Guys, it is just change of order. Everything under what? Multiplication. This is exactly what we want. So the best answer was going to be on C. The changing of the order of the given factors does not affect the resultant of your product of the given numbers or the given terms. All right, on number 8, we are given what is the additive inverse and multiplicative inverse of this. So there are two, additive and multiplicative. So without wasting our time, guys, we do understand for an additive inverse, if I am to add, let's say, x, it must be added to its negative, the additive inverse of x. It must be added to a negative x so that we obtain what? A 0. So we are simply saying the additive gives us what? A 0 if we add 2 to its negative value minus 2. 3 to its negative value minus 3. So if I'm given 1 over 5, guys, if I put 1 over 5 here, what is it that I'm supposed to add? I'm supposed to just the same 1 over 5 with what? With a negative. The only thing that is affecting is a negative minus x. The negative there. So that's the additive inverse was supposed to be what? Negative 1 over 5, putting a negative there. So this is what we need for additive. Let's move on to the multiplicative inverse. What is the condition? A number, when multiplied to its inverse, 1 over that number, 1 over x, we must obtain 1. I talked about that, guys. A number to its inverse, 2 times its inverse, 1 over this, 1 over 2. We must get a 1. So in our case, what is our number? Our number is 1 over 5. So if I say 1 over 5, that's our number, this one. It must be multiplied to its inverse, 1 over it, 1 over that number, which is what? Which is 1 over 5. We must get a 1. So here we are saying a number to its inverse. So this is our inverse, 1 over this. Let's simplify and see, guys. 1 over what? 1 over 5. Use your calculator and see. That's what? That's a 5. All right, it's because I used that rounding off before. So that's a 5. So the multiplicative inverse is 5. Simplify. If we simplify 1 over this, guys, you cannot leave your answer like that. You can simplify this. So that's what? That's a 5. Okay. So according to our answers, additive inverse, we said what? Minus 1 over 5. And multiplicative inverse, we said simplified to 5. So where do we have minus 1 over 5 and 5? That is what? On B. On B. So 8, the best one was going to be what? Was going to be B. So these are the typical questions that you might be given. That was it on number 8. Let's consider question number 9. Simplify. So there we are simply going to apply our BODMAS, guys. There are brackets. Where there are brackets, apply those. All right. So that is BODMAS. Some they use BOMDAS. One and the same. Brackets. There are brackets here. There's a bracket here. Okay. So what is, okay, let's simplify inside the bracket. 3 minus 5, that's what? Minus 2. Then it's going to be 6 minus times minus is a plus. Minus times minus, that's a plus. So it's now a plus. Plus 9. All right. Minus times minus the bracket. Minus times minus, that's a plus. So that's plus 15 divide by 3. We no longer have brackets. So we move on to division. There is a division here. So that is 6 plus 2 plus 9 plus 15 divided by what? 15 divided by 3, which is 5. So that's a 5. So that is going to give us, if we add everything, guys, we're going to obtain 22. All right. So that's 22, which is on A. All right. So the best answer there was going to be A according to our BODMAS or BOMDAS, one and the same. What is the value of the expression that we are given there? What is the value of this expression? So there is a product. Okay, still BODMAS, guys. BODMAS. BODMAS. Okay, so let's consider the brackets 5 times 3 times 4. It's a product, but those are brackets at the same time. So simplify them. 60 minus 5. There is an inner bracket which has got here, a negative there, the minus 4 multiplying 3 before you consider those outer brackets. Let's consider the inner bracket first. So in that case, it was going to be what? It was going to be like this. It was going to be like this. There is a 3. Then if I multiply negative 4 times 3, that's negative 12. All right. In actual sense, guys, there was no need for me opening these bigger brackets. Let me just do it like this. All right. So there is a 3 minus 4 times 3, which is what? Which is 12. So I'm just going to have something like this. The denominator is considered separately from the numerator. So therefore, you can simplify it on its own. Negative 3 minus 2. That's what? Minus 5. Simplify it. Okay? If we are to consider what we have now, there is a bracket which we can simplify. We're still having a bracket. So what is it that we are going to obtain? 3 minus 12. That was going to give us what? Negative 9. So this was going to give us negative 9. So negative 5 times negative 9. So it was going to be 60. Negative times negative, which is positive. I'm saying 5 times 9, which is 45. Everything over negative 5. So simplifying the numerator, that was going to give us 105 over negative 5, which is negative 21. So the best answer was going to be on what? On A, just like that. 11, evaluate this. The cube root of 125, we do know this one, that is 5, guys, all right, minus. This is on its own. So simplify 3 squared on its own, which is 9, plus a 0 plus 1. Everything over what? Minus 4 plus the square root of 121, which is 11, minus the cube root of 64, which is 4. Use your calculator, guys. Add, simplify the numerator, everything. 5 plus 1, that's 6. 6 minus 9 over what? 11 minus 4, that's minus 8. So it was going to be something like minus 3. 11 minus 8, that's a 3. So guys, this is what? Negative 1, isn't it? Negative 1, which is what? Which is D. Okay, okay. That was again a direct question there. Question number 12, again, it is to simplify. Let's see, there is a cube root there. Cube root of 27, guys. We know this is, we can simplify this as 3. There is 50 over 2, which is what? Which is 25. Then the square root of 25, which is what? Which is 5. So that's plus 5. Everything over what? Guys, this is the denominator here. This one, it is a denominator. It is just like a single term. So when you simplify it, it is best for you to even just open brackets for that. All right. You consider it as a single term. So this is 4 squared 16 minus the cube root of 8, which we know as what? As 2. Everything over the square root of 49, which is 7. You close the bracket to represent the denominator as a single term. But remember, everything here is raised to the exponent of what? Of 2. Okay, so this is where we are. The numerator on its own again, just like the previous case, 3 plus 5, that is 8. The denominator, it is a single term, just like I explained before. So here, please treat it as a single number. 16 minus 2, that is 14 over 7. It's a single number, this one, but raised everything to the exponent of 2. All right, so that's it. We're going to have 8 over what? We can simplify our denominator now. 14 over 7. It's a single term, remember, that's a 2. So it was going to give us a 2. Everything raised to the exponent of what? Of 2. So this is it. 2 into 8, that's 4. Then 4 squared is 16. 4 times 4. That was going to give us 16. So the best answer there was going to be on what? On A. Simplify on number 13. Those are laws of exponents. Same base on a product. You add the exponents, remember. So 3 times 2, that's 6. The exponents we add 3 and 2. So 3 plus 2, that's what? That's 5. 6n to the exponent of 5, that's A, is the best answer. 14, simplify this to the exponent of 3 minus 2x squared y raised to the exponent of 3. Each and every term that we see here will be raised to the exponent of 3, including a negative. But remember, a negative, when raised to an odd exponent, it remains as a negative. So it was going to be negative 2 is raised to the exponent of what? Of 3. X squared is also raised to the exponent of what? Of 3. Y is also raised to the exponent of 3. Every term. Every term. So that was going to be minus 2 to the exponent of 3. 2 times 2, 3 times. That's 8. An exponent to an exponent, remember, you multiply those exponents. So 2 times 3, that's what? That's 6. Here it is already simplified, guys. So which one is it that will be our best answer? That is B, according to what we are given there. So that is it on number 14. Moving on to number 15. Evaluate this. Okay, there are so many ways. You can just simplify each, isn't it? Then you multiply them. Or you can just consider to say, let me write this in simplest form. 2 to the exponent of minus 2, 6 to the exponent of 3, 3 to the exponent of minus 2. As in the simplest form, it means as prime numbers. Try to rewrite numbers as prime numbers. 2, 3, 5, 7, and so on. 6 is not a prime number. So we are supposed to rewrite as prime factors. So 6, 2 times what? 2 times 3. So meaning to say I can rewrite this as, in place of a 6, we could have written it as 2 times 3 raised to the exponent of 3 as it was before. So we are back to the condition that we had before where everything was raised to another exponent, and I said each will be raised to the exponent 2 to the exponent of 3 times 3 also raised to the exponent of 3. All right, then there is this one at the end, 3 to the exponent of minus 2. We are back to what we had in the previous question where there is a product and we are considering to say the bases are the same. We are multiplying, we add the exponents. Isn't it, guys? It is the same thing. Multiplication where there are same bases. So this is what we have, all right? Sorry. This is what we have. Same basis, the base of 2. The base of 2. So you add the exponents there. All right, so you're going to add the exponents, 2 to the exponent of minus 2 plus what? Plus 3, which is 2 to the exponent of 1. That's a 2. All right, so there, guys, it was going to be 2 times. You do the same thing, guys. It was going to be 3 to the exponent of 1, which is 3. And 2 times 3 is what? Is 6. So the best answer, or number 15, was going to be A, which is which is what? Where we've got a 6. All right, number 16 of the given numbers, simplify this. Okay, guys, here, exponent. I explained this law before, so I'm not going to waste much time here. That's negative 3 into this raised to the exponent of negative 3 is just negative 1 times negative 3, which is what? Positive 3. 2 and negative 3, that's what? Negative 6. You're multiplying, guys, remember? Times the same thing, x to the exponent of what? Negative 5, y to the exponent of negative 5. So the minus 3 is outside of the bracket. It can just multiply, guys. It's just like minus 3 times ab. It's minus 3ab. So what is the difference here? No difference. So it's minus 3x cubed y to the exponent of negative 6 times x to the exponent of negative 5 y to the exponent of negative 5. From this, we are back to the application where we're going to multiply. Here, there's just a 1. So minus 3 times 1 is minus 3. The x and the x, same bases, I multiply. So I am multiplying same bases. What do? I add exponents. Add. So plus and minus, that's minus. So it was going to be 3 minus 2, 3 minus 5, which is minus 2. So it's going to be x to the exponent of minus 2. Okay, the y and the y there, negative 6, negative 5. So that was going to negative 6 plus minus 5. Remember, we are multiplying. So that's minus here. So it was going to be negative 11. Guys, okay, this is what you're going to have at the end. But we do not have that here. Why? Our answers has been converted to positive exponents in a simplification. So we need to get that negative exponent. X to the exponent of negative n is 1 over x to the exponent of n. Get rid of the negative by 1 over. So that's negative 3. It is the only one that we consider there as our constant. So there is no need of you considering this. Guys, we do not have the exponent there. So leave it as it is. It is this one that has a negative exponent, the x. So it's going to be 1 over x squared. The y also, it has a negative. So that's 1 over y to the exponent of what? 11. Okay, so that's the -3 multiplying the numerators, guys, on top is simply -3 over what? X squared y to the exponent of 11. So which one is the best answer? That was going to be on what? On C. According to the answers, the one that matches this exactly is what? Is C. Okay? Yeah, guys, that's it. That's it. Number 17. Simplification again. Just look into these. We can see that, okay, some basic laws here. 1 over x to the exponent of -n. If there's a negative there, it's going to change to x to the exponent of n. So this is exactly what you needed here. So it was going to be y squared plus y squared. 1 over this. So it's x to the exponent of n. So that's y to the exponent of 2. You just get rid of that negative over. That's a product here. Remember, a product, you add the exponents. So it was going to be 2 plus 2, which is y to the exponent of 4. Everything to the exponent of -2. There is addition. Addition. These are like terms, guys. Y squared, y squared. Same exponent. So you're going to add 1 plus 1, which is 2y to the exponent of 2. Everything over y to the exponent of 4 to the exponent of -2, which you can simplify as a division. Remember division now. You subtract your exponents, x to the exponent of a, x to the exponent of b is going to be x to the exponent of a minus b. So you're going to subtract our exponents, 2 minus 4, which is -2. So it was going to be 2y to the exponent of -2, but everything raised to that exponent of -2 that we see here, it is for everything that we have. So this is what we have: a number to the exponent, the term also to the exponent. To get rid of the bracket, everything must be raised to the exponent of what we see there. So that's 2 to the exponent of what? -2 times y to the exponent of -2 to the exponent of -2. So it's to the exponent of -2, but don't forget this one, -2 again. So that's it. Guys, we know 2 to the exponent of -2 is 1 over 4, guys. 1 over 2 squared, which is 1 over 4. So that's 1 over 4 times -2 and -2. These are exponents, so multiply them together. So that's y to the exponent of 4. So 1 over 4 times y to the exponent of 4 is the 1, which is the same as b. This one is the same, guys, as writing as y to the exponent of 4 over 4, because this is numerator to numerator, denominator to denominator. So the best answer there was going to be what? On B, according to these answers. So you see, guys, that is how they can give us these questions as, and you just need to figure out your simplification. The square root of this, okay, remember I said, guys, on our revisions later, that for a square root, the cube root, the fourth root, is it the fifth root? Where there are exponents, you just divide by this number that is what? Inside the root. So square root, there's a number inside, it's a 2. It's only that they do not show it. All right. So we know the square root of 4, which is 2. But for the exponent now, so it's going to be 6 divided by 2. X to the exponent of 6 over 2, which is what? Which is 3. The same thing here. -2 divided by what? By 2. Y to the exponent of -2 over 2. We just divide by the number in the exponent. So that's y to the exponent of what? -1. Guys, we are back to that law. Exponent to exponent. Remember, I said you multiply. So that's -4. Everything over what? Any number to the exponent of 0, even the whole bracket, gives us what? 1. Times y to the exponent of -3. which you can leave it like this because there's also a y there on top. So just leave it like that as a -3 so that you apply the laws of exponents, guys. So that was going to give us what? 1 times any number, guys. That number remains as it is. So meaning to say, I'm going to consider the 2. It was just like 2 divided by 1, which is just a 2, guys. All right. The x on the numerator there, this one times this one, it's a product. So product, you add the exponents, -4 plus -4. So it was going to give us -3. X to the exponent of 3 minus 4, which is what? Which is -1. So that's x to the exponent of -1. Y there, y and y is under a division. So you subtract the exponents, -1 minus -3. -1, you subtract the -3. So that's a plus there. All right, so it's gonna be -1 plus 3, which is what? Which is y squared. So that's y squared. So we simplify this. This is gonna give us what? Y squared. So this is where we are, guys. 2x to the exponent of -1 y squared. X is carrying a negative exponent. So, guys, that one, we're just gonna write it in the denominator as we saw before. So 2 and y squared, they do not have negative exponents. It is only x. So it's x to the exponent of what? Of 1, which is same as what? Which is same as x. So 2y squared over x, the best answer there was going to be on what? On D. All right, that's it. Yeah, that's what we had on this one. A little bit direct from the approach. Yeah, you can use any approach. Which statement of these ones best describes the rule of the pattern? Add the 2 to these guys. Okay, you just test and see. But without wasting time, guys, it was just a matter of adding 1. Add 1 to the previous term to get the next. You add 1 here and see if you're gonna get this, guys. This one was just test, okay? For the sake of time, let's get our calculator to the normal mode. So if I take the first one, it is 1 over 2 plus what? I'm going to add 1, as we can see, 3 over 2. So 3 over 2 plus 1, I'm supposed to get what? 5 over 2. Let's do that. Plus 1, 5 over 2. Plus 1, we must get 7 over 2. Plus 1, we must get 7 over 2. So that's B. It was a direct. What are the next 2 terms of the sequence? Okay, this type of a sequence, guys, 0, 1, 1, 0, 1, 1, then 2. What is it? What is happening here? Let's try to study this. If we study this properly, we are going to see that it's a Fibonacci sequence, this one. A Fibonacci sequence. What is this Fibonacci sequence? It is a type of sequence. Normally, it starts with a 0 as it is, then it repeats 1 and 1. It is a type of a sequence where, or let's just say a series, if we consider a series of numbers, where each number is the sum of the 2 previous terms. Right? Let me write it down. A series of what? Of number, where, all right, of numbers, okay, where each number there, where each number, you understand me very soon, where each number is the sum of the 2 previous terms, or 2 previous ones, is the sum of 2 previous ones. So normally starting with 0 and it repeats this 1, 1, then you think of the Fibonacci sequence. two previous. For example, these two numbers, the previous ones, if we add them, if we add them, combine them, what do you get? 0 plus 1. It's what? It's a 1. Two previous terms. 0 plus 1 gives us a 1. Okay. Let's move on. 1 and 1. Let's add 1 plus 1. What do we get? 2. Let's move on. 1 plus what? Plus 3. What do we get? 1 plus 2, I mean, that's a 3. Let's move on. 2 and 3. Two terms. 2 plus 3 gives us what? A 5. Continue like that. You're going to notice that here, if I add these two terms, the 3 and the 5, I'm going to get 8. That's the next term. But they said, what are the next two? Not only one, but two. So we continue in the same manner of adding two terms before previous to get the next term. So 5 plus 8 is what? 18. So these are the two terms that we need. 8, 18. So the best answer was supposed to be what? A, where there is 8 and 18. All right, so that is how it can be like. Okay, you just have to study the numbers, study the sequence. The same thing with this one. They are saying which pattern represents pattern 4. There is pattern 1, pattern 2, pattern 3. So what about pattern number 4? Which one best describes pattern number 4? How can I see that this is pattern number 4? If we study properly here, there is something that is common that is happening here. The first pattern, if we consider, there's something about, okay, let's consider this one, this thing, and this one. Remove them. This one here at the corner here, and this one at the corner, the anchors. This one, and this one at the anchor. We can see each and every has got 3 anchors in each part. In each part. There are 3 anchor dots. 3 anchor dots. In each pattern, in each part that we see there, in each. So if we get rid of the anchor dots, we can see there is something remaining here as a row and as a column. 2 dots in pattern 1. In pattern 1, we have 2 dots in this row, 2 dots in a row, and 2 in what? Column. Which is the same thing here. 2 for the row, 2 for the column here. Let's get rid of this one. Let's see. Also, we said, all right, the number of dots, there are 2. So if we say, guys, okay, there is just 1 row, 1 column. So if we put it this way, I might confuse you. Let me put it in a simpler way. Let's just say 2 dots, full stop. Then 1 column, 1 as this one, the row, and this column here, 1, only 1. So there is 1 row, 1 column. So 1 row, 1 column. All right, let's look at this one so that it can be easier. This is a row, and this one is what? This one is a column here. How many dots? 1, 2, 3. Like in terms of the dots that are lying in that row, like 1, 2, 3. So you can just say 3 dots there. How many columns? How many rows? I mean, 1, 2. We in what? There are 3 dots in what? In 2 rows. In how many columns? 1, 2. Again, in 2 columns. Here, if we count properly, we are going to see that it's 1, 2, 3, 4. As the same, guys, there are 4 dots which are found in how many rows? 1, 2, 3. In 3 rows and 3 columns again, just like here. 3 dots, 1, 2, 3, 4 dots, which are found in what? In 3 columns. So if we look into this, guys, it was going to be a continuation. For pattern number 4, I can even tell to say, if we are consider that pattern 4, the number of dots which lie in the rows and columns, they are supposed to be, they are supposed to be 4. Remember, 5 now, because they are increasing. 2, 3, 4, now they are 5. So they're going to be 5 dots, and the number of rows and columns, they must be increasing again. It was 1, 2, 3. Now there are 4. So we must have 4 rows and what? Remember, the number of rows and the number of columns are the same. The number of rows and the number of columns are the same. And do not forget those 3 anchor dots. So let's look for that one. That has got 5 dots. Okay, so how many here? 1, 2, 3, 4. So this one is totally out. We need 5 dots. So A is totally out. B, it is 1, 2, 3, 4, 5. Yes, there are 5 dots, but how many rows? 1, 2, 3, 4, 5 rows. The number of rows, they are not matching. So it's totally out. Okay, before we look into C, let's look into D. How many dots? 1, 2, 3, 4, 5, 6. The number of dots that we are expecting in each row, guys, it's not the one. So D is also totally out. All right. If we look into C, how many dots? 1, 2, 3, 4, 5. This is what we want, but let's see the rows. How many rows? Are they 4? And the columns, are they 5? Are they 4? The rows, all right. So here, as we consider here, how many rows do we have? 1, 2, 3, 4. There are 4 rows with 5 dots. How many columns do we have? The same 4 columns. 1, 2, 3, 4. Exactly 4 columns. We have exactly what we need here. And do not forget our 3 anchor dots. Do we have those 3 anchor dots? There is the anchor. All right, let me put it this way for those anchors. There is this one, there is this one, there is this one, 3 of them. So guys, the best answer was going to be what? C, according to the way the pattern is supposed to continue. The pattern, the way it is supposed to continue from the original one that we are given. You can trace, study it, how it was proceeding from one to another. Then you just consider your answers to say which one is proceeding in that manner. On question number 22, there is a guy who makes a pattern with the squares. So it was a pattern, this one, a square, a square, a square. What will the area of the 9th square be? The area of the 9th square. So this type of a question is from your number patterns. You can work with the area. You can work with the area straightforward. Area. The first square, the second square, the third square. Let's consider what is happening in terms of the area. Remember, area is side squared. So area, side squared, 2 times 2, which is 4 square centimeters. 4 squared, 16 square centimeters. 6 squared, 36 square centimeters. So you're saying the first square has area of 4, the second area of 16, the third area of 16, of 36, I mean. So what is the relationship in terms of the area? How is our area given in terms of our Tn for the area? All right, area, guys, because we're talking about n, we can think of n squared because it's area. So you think of what? N squared. But if we consider that to say it is the first term 1 and we put 1 here, 1 squared, it does not give us a 4. The same thing for 2. 2 squared does not give us 16. So what happened to the n squared for us to get 4 instead of what? Instead of a 1, because the first term you're supposed to say when n is 1, you substitute 1 there. If you substitute a 1, it was going to give us a 1, not a 4. So what happened to get a 4? Let's multiply by 4. Okay, let's move on when n is 2. 2 squared is what? Is 4. But the area is not 4 here. The area is 16. So what happened to get a 16? Let's multiply the same 4 that we multiplied here on 1. 4 times 4, 16. Exactly what we want. Okay, no problem. Let's prove the third one. 3. When n is 3, 3 squared is what? Is 9. But 9 is not the area there. What happened? Multiply by 4. 9 times 4 is what? 36. So it simply means our Tn is not supposed to be n squared, but it's supposed to be n squared times 4, which simply means what? 4n squared for area. For area. This is the Tn from area. So meaning to say, for the 9th square, I can simply substitute T9. So that's 4 times what? 9 squared. Just like that. 4 times 9 squared, that's 81 times 4, which is 324. Area, square units, square centimeters. So the best answer was going to be A. Okay, we used area there. But someone could say, okay, what if I just use the sides as they are? Why are we working with the area whereas we are given sides? This is the first, the second, the third. So it's just like T1 is equal to 2. T2 is equal to 4. T3 is equal to 6. What is happening here? Let's try another way dealing with what? With sides. We want to find Tn for sides. So I'm saying 1 corresponds to 2. 2 corresponds to 4. 3 corresponds to 6. As we can see from this number pattern, we can see that there's a difference of 2 here. A difference of 2. So that's a linear pattern. So Tn is supposed to be given from our Bn plus C or Dn plus C, guys, whatever concept, where D is the common difference, the constant difference, which is what? Which is 2. So Tn is equal to 2n plus C. I must find the value of C. From where? I can use the first term. T1 is equal to what? To 2. So if T1 is equal to 2, substitute that and find C. So 2 is equal to 2. T1, n is 1. So 2 times 2, that's a 2. So 2 minus 2, that's a 0. All right, 2 minus 2, that's a 0 there, which gives us what? C. So C is simply what? A 0. So meaning to say Tn is equal to 2n. It's a number pattern. representing what? Sides. Take note. Sides. So meaning to say, for the ninth square, T9, for the ninth square, its side, its length is going to be 2 times n, which is what? Which is 9. 2 times 9. That's 18 side length in what? Centimeters. We have the length or the side of the square. What is its area? If the length is 18, what is the area? Area is side squared. So 18 squared. Guys, we can list so many ways here and we're not going to be able to finish. So many ways. So many ways we can list them. We won't be able to finish. It is in your hands. So this is a typical question paper for everything that you have covered in your syllabus, actually. If you are in grade 8, you want to learn more, this is for you. Again, it's not just to attempt. You attempt it after you think twice to say, am I to do it or not? Okay, on question number 23, which of the following are like terms? As we do consider like terms, supposed to be exactly the same. Exactly the same. Whether we have got our variables. Supposed to have exactly the same thing. So there is a p squared. That alone, guys, it's out, totally out. Because of those exponents being different. Here to say there is a q squared. Here there is r squared. It's not the same. It's not the same. There is a q squared. Q squared, squared. But this one is just q. That alone, it's totally out. There is r here. There is r squared. Guys. Totally out. There is p. There is p. Q squared. R and R. Exactly same term. That's exactly the same variables raised to the same exponent. It will make the two to be what? To be like terms. So the best answer was going to be on number 23, was going to be on D. The number 24, what is the exponent of the term with the smallest coefficient? The smallest number. So you test the coefficients. -2, +3. There is -1. We're talking about coefficient. This one is a constant, guys. It's a constant. But it is the coefficient of what? X squared of x raised to the exponent of what? 0. If you have to write that one. But they say the smallest. You compare the numbers. Which one is the smallest? -2. From your number line, there is 0 here, -1, -2, -3. As you go to the left, the far left, that's the lesser the values are. As you go to the right, the bigger the values are. So -2 compared to -1, -2 is small. So of all these, it is the smallest because this one is +3, guys. +8. So -2 is the smallest coefficient. It is our smallest coefficient. But let's answer the question. It is, What is the exponent of the term? The term that is there. What is the exponent? It is 3. So the exponent is the one that we need, which is what? Which is 3. So the best answer was going to be on D, where there is a 3. On question number 25, how many terms are in the expression? How many terms? A, B, C, it's a single term because of the product. It is different from A plus, B plus, C. There it is a single term, a single term, a single term. Here it is considered as a single term because of that product, or it can be a division. It's a single term. So take note. Take note there. So here there is a product of these two, of these. It's a single term because of that product that we see there. Single term. Same as the 5x, it's a single term. Same as the y squared over 3, it's a single term. Terms are separated by the plus or minus, plus or minus. This whole thing to this whole thing is separated by a minus. This one by a plus. So these are the terms 1, 2, 3. There are 3 terms on D. Okay, just like that. Question number 26, simplify this. All right, if we are to simplify, there is a bracket, so just expand the bracket. 2y squared minus 4y minus 1. So the bracket, the term to expand the bracket is the minus 3y squared outside of the bracket. Remember, guys, multiplying. There's just going to add the exponents. So minus 3 and 2, that's going to be minus 6. If we distribute here, that's going to be negative 6 y to the exponent of 3. This is 1 plus 2, which is 3. Minus 3 and minus 4, that's a positive 12. That's a 1 here, so we add 1 plus 1, which is what? Y squared. We are done with the bracket. We are done. But there is a minus 1 outside of the bracket. It is on its own, that one. So this is it. This is it. This is what we got. And which one's the best? That was going to be on A. On A. Yeah, on A. So the best answer there is A. 27, simplify this. There is a bracket as well. So there is a need of you expand the bracket. Just distribute just like the previous case that we had. It is just going to be a direct thing, guys. Okay, 15y to the exponent of 3. The minus 3 and the minus, it's a product. Minus times minus, that's a positive 3y squared. 1 plus 1. You add the exponents. Minus 3 to the positive 2, that's minus 6y. Everything, okay, there is 6y squared. Don't forget to add it there. Everything over 3y. Before we are to say, let's divide each and every term by 3y, guys, try to evaluate, simplify the numerator. Where they are like terms, simplify them. Such as here, the 3y squared, the 6y squared. Those are like terms. 3 plus 6. Add the coefficients. All right, so in the order of exponents, starting with the highest exponent, 15y to the exponent of 3. Okay, so here we're going to add 3 plus 6, which is what? Which is 9. So that's 9y squared minus 6y, this one. Everything over the denominator, which is 3y. Basically there, I'm simply going to divide each and every term to the denominator. This is our basics of our algebra, guys, working with those algebraic expressions, this and that. Each and every term divide by what? by 3y like that, so that we're gonna have 3 into 15, that's 5. Dividing, we subtract the exponents, so 3 minus 1, that's 2. 3 into 9, that's a 3. We subtract the exponents, 2 minus 1, that's 1, which is same as just y as it is. Minus the y, and the y is gonna cancel, so 3 into 6, that's a 2. 5y squared plus 3y minus 2. Guys, all this, you have to go through it in your simplification. But if you know the basics, guys, you're not gonna have all this process. You're just gonna limit in terms of your understanding. Say, okay, at this stage I can even just leave it, move on to this, evaluate. Okay. Simplify on number 28. The square root of, remember I said there is a tool that they do not show you, but it is there. Knowing that is going to help you. All right, anyways, these are like terms, guys. Y to the exponent of 8 and y to the exponent of 8. Same variable and exponent. So simply add, remember, like terms, you add the coefficients of the given variable. So here there is a 1, y to the exponent of 8. So that is like what you actually see there. It is y to the exponent of 8 plus 9 over 16y to the exponent of 8. So I see the 1 and the 9 over 16. This is what I see as the coefficient. So I add those two. 1 plus 9 over 16. Just like that, guys. Direct and straightforward. That's 25 over 16. So we need the square root of 25 over 16. 25 over 16 y to the exponent of 8, which we can simply evaluate the square root of the answer on our calculator there for the number 25 over 16. 25 over 16, its square root is going to be what? 5 over 4. But what about the square root of y to the exponent of 8? That's where I was saying the number inside of the root sign to the exponent. You divide y to the exponent of 8 over that number inside of the root sign. Guys, you have evaluated for the cube root, for the square root, for the fifth root, for anything that you are given by that condition. Then exponent divide by the number inside of the root sign, 27 over 3. You have simplified it. So here, 8 over 2, that's what? That's a 4. So it's going to be y to the exponent of a 4. So that's it. From this simplification, and looking into the answers, guys, this one is best as what? C. This is the same writing as C. All right. Number 29, from this expand, what is the product? They simply say expand. To the exponent of 2, there are two brackets. Yes, we can use, yeah, the a minus b squared, which is a squared minus 2ab plus b squared. I'm going to explain it later on. All right, but anyways, two brackets, simply expand. The FOIL method, one bracket expands the other. Simpler like that. So let's consider the first term, which is 4x. So we are going to have the 4x times the 4x. So that's 4 times 4, which is 16x squared, x and x. The 4x to the minus half. So you multiply 4 times minus half. That's minus 2. But there is x. There is x there. We are done with the 4x. It multiplied everything in the second bracket. We move on to the minus 2. It does the same. Multiply to this. Minus 2x. the minus 1 over 2 and the minus 1 over 2. Minus 1 over 2 times minus 1 over 2. Negative times negative. That's what? Positive 1 over 4. X and x, these are like terms. So simplify minus 2x and minus 2x. Those are like terms. So it was going to give us 16x squared minus 2 minus 2. That's what? Minus 4x plus 1 over 4. So looking into the answers, we can see that the best answer was going to be what? B. Okay, but I say there is an expansion which we are also used to, and that is best even for our grade 10 mathematics revision. Remember, if we are given the a minus b squared, the first term and the second term, raised to the exponent of 2, there is a negative there. So we are saying there is our first term, which is our a, and the second term, which is b. So it's supposed to be a squared. What is a squared? The whole term, 4x squared. So it's 4 squared, which is 16x squared, everything to the exponent of 2. So that's supposed to be 16x squared. Minus 2ab, that's minus 2 times our a, which is 4x. Our b, which is what? 1 over 2. That is a and b. This is the b, not the minus. No. The minus is here for the sign. Taking the b as it is. So that is this one and this one was going to cancel. So minus times 4, that's minus 4x plus b squared plus b squared plus b 1 over 4. That's 1 over 2 squared, which is what? 1 over 4. So guys, just like that. These are laws, basics of our algebra to be used again. As long it is valid, apply it. As long it is what? Valid. Use it. Number 13. What is the numerical value of this expression if we are given this? Simply substitute. Substitute what you're given. So that's 9 into p squared minus 1 squared minus 8 into q 0.125. Yes, you can have it as a fraction. You can just have it as a decimal. That's why we have got the calculator, isn't it? And our R is 1 over 2. Okay, that's a single term. So like I said, guys, you can just use your calculator. It knows decimals. It understands decimals as well. Use it. It understands them. So that's a 1. 8 times 0.125 gives us what? A 1. The product, the whole of this, 8 and 0.125 is a 1. So it was going to give us, that's minus 1 there. Okay, minus 1 squared, that's 1. And 1 times 9 is what? Is 9. Everything over 1 over 2. Okay, so that's it, guys. 9 minus 1, which is 8 over 1 over 2, which is simply 8 times 2. 8 divide, you're dividing, guys. The moment you multiply, remember, you invert the second fraction. So that was going to give us a 16 at the end, which is C. Or just use a calculator here to divide 8 over that. 8 over what? 1 over 2. Guys, you are told to use calculators, isn't it? So use it. So that is it. It was going to give us 16, which is on C. So that was our question 30. Then 31, factorize. Given a difference of 2 squares, 25, a perfect square, a square, a square, a square, guys. Simply look for what? Their square roots. The square root of 25, which is 5. The square root of a squared, which is a. What about the square root of 16, the 4, the square root of b squared, which is b? 1 is going to subtract, 1 is going to add. Just like that. Okay? No, that is a B there. 4 what? 4B. Just like that. So there is here on A, the best answer, guys, is gonna be on A there. Factorize this, all right, from the trinomial that we have. The coefficient of y squared is 1, guys. So simply have 2 brackets y and y, factors of 18, products. We need factors of 28, sorry, 28, which will add up to negative 11. Guys, already there's a hint on your answers. There's already a hint there that you can, okay, there is a 7 and a 4. The two numbers that you know, they are supposed to be 7 and 4, guys. But the question is, on the sign, to get a 28, it's either they are both positive or both negative. Guys, to get a positive 28, they must be both negative or both positive. But the question is, which one, when we add, we are supposed to get this one, negative 11. If we add these two, we get positive 11, not negative. So it's totally out. So this one, if we add, we get negative 11. This is what we want. So minus 7 minus 4. Minus 7 minus 4, that's on what? On C. So the best answer according to this one was going to be on C. So we're going to move on. That is how these questions, guys, will be given, as you just have to be careful. Okay, just have to be careful. All right, 33 factorize. Okay, 9 is common here. 9, 9, 9 here. Guys, just put out 9. 9 and 9, that's going to be p squared. 27 divided by 9, that's 3. P minus 90 divided by 9, that's negative 10. So I'm going to look for the two factors here because I'm having this trinomial and there is a 1 there. So guys, just gonna, you have two brackets, the P here and the P, factors of what? Of negative 10, which will add up to 3. Already I have a hint. If you check, there's a 5 and a 2, but I just need to know on this 5 and a 2 to get a negative 10, 1 has to be negative. So it can be negative 5 or it can be 5 and negative 2. Already there's a hint, guys, on your answers. Don't waste time. So which one now? When we add, we are going to get a positive 3. When we add, if we add here, we're going to get a negative 3. If we add here, a positive 3. So this is what we want. 5 and what? 5 and minus 2. 5 and minus 2. 5 and minus 2. Positive 5, minus 2, and a 9. So the best answer is what? Is on B. All right, that was going to be on B on that one. Just like that, just like that. All right, same concept on question 34. If you can see the numerator there, 2 is common. Factor that 2, guys. Looking into this, 2 is common. So if I factor out 2, what am I going to have? 2 and 2 cancels, so that's going to be a squared minus 10 and 2 minus 5, 12 and 2, that's positive 6. We are dividing there. Okay, the denominator already, there's a bracket which is common, the a plus 2 bracket. So I can factor the a plus 2. And what am I going to remain with? There is a, there is what? Minus 3. So that is it. We are going to have two brackets from the trinomial in the numerator where the coefficient of a squared is 1. So we're going to have two brackets, a and a here. Factors of 6, which adds up to negative 5. Factors, products of 6, 3 and 2. But to get a negative 5, we must have negative 3 and negative 2. If we multiply these two, we get positive 6. If we add them, we get a negative 5. This is exactly what we need. Negative 3, negative 2. Everything over what? The denominator is given as we factorized before. So that's the idea, guys. A minus 3, and a plus 2. Anyway, the way that you write anyway, right? So this and this are the same. Let them cancel. So the answer was going to remain as 2 into a minus 2 into a plus 2. Right, which is on C. So the best answer there was going to be C. Okay, then moving on to question 35. All right, there is something that they just wanted to play around with you guys here. So you test, guys. You can see there is something here that is common. Okay. The numerator also, there is something common. Why? These are two terms. Remember, I said a product is referred to as a term separated by this negative that we are seeing there. So it makes this whole part to be a single term. Why? It is a bracket. There is a bracket. So that multiplication alone makes it to be a single term because of that multiplication. So we can look into these two terms and ask ourselves, what is common between the two terms? 48 and 3. 3 is the highest common factor. We can factor out 3. R and R there is common, so we can factor out 3R. That's our highest common factor. Remember the HCF. So 48R divided by 3R, what are we going to have if we divide? So that was going to give us 16. Okay, that was going to give us 16. Let me do this way. Let me do this way. So it was going to give us a 16, this one. Then we divide here, the 3R there, definitely, guys, and the 3R is going to give us what? It's going to give us a 1, cancels there. So we were going to remain with a 1. 1, guys, does not even affect. It's just the same as P plus Q squared. It is a 1 that was going to remain there. You can just leave it like that. 1 does not affect anything. In the denominator, we can see that we have the same 3 common throughout. Into 12, 3. There is 3 in 12, guys, remember? So we can factor out 3. R is also common. There is R here, there is R here, there is R here. So 3R is common in the denominator. So let's divide 12R to this, the one that we factored out, 12R over 3R, that was going to give us 4. 3PR divide by the 3R that we factored out, that we're going to remain with what? Positive P. That's a positive. The 3QR divide by what we factored out, 3R there, we're going to remain with what? With the Q, which is positive. So this is what you're going to remain with, of which here there was no need of even having these brackets like this. You can just have a proper bracket like this. Okay. The denominator, we factored out 3R. The numerator, we factored out 3R. We can cancel that. It's a product, remember? So that can cancel. Looking into the numerator, guys, we can see that there are two terms again. There are two terms. 16 and this whole bracket being squared. Being separated by this negative. And thus being a difference of two squares. It's a perfect square. It's also a perfect square. So as we consider perfect squares with a negative, that's a difference of two squares. A squared minus B squared is going to give us A minus B into A plus B. So 16 here is the same as 4 squared. So we have our A and our B, the P plus the Q, the whole of it, this one, raised to the exponent of what? 2, 2, 2, 2. So we have A and B. A and B, A and B. That is the most important thing. So from this, A minus B, A is what? The 4. Minus our B, which is the bracket, this one as it is, the 1 raised to the exponent of 2, which is the bracket of what? P plus Q. So this is our A, this is our B, A minus B. Okay, so we're just going to put it this way. That's our A minus B. Into what? A plus B. So another bracket, our A, which is what? Which is 4, plus our B, the bracket, P plus Q. Everything over our denominator, 4 plus P plus Q. Guys, by just looking into this, we can see that this one is an addition throughout. So if you expand these, it is going to be exactly the same as this one. Exactly the same as this one. So this can cancel. You are left with the 4 minus P plus Q, which is not given here. So what happened? They simply expanded the brackets there with the negative. So distribute with the negative, the bracket 4, minus 1 times P, minus P, minus 1 times Q, minus Q. So it was going to be 4 minus P minus Q, which is what? Which is the best answer was going to be on C. That is the condition on C. So they can give us these typical questions. So you have to work out as many questions as you can. Question 36. What is the value of M? It is simply solve for M. Guys, just divide there. -4, -4. That's it. So M is equal to what? Negative, negative cancel. 2 over 4 is what? 1 over 2. So the best answer was going to be D. Then 37, what is the value of A? Again, here we can just cross multiply. 1 times A, that's A. 7 times 2, that's negative what? 14. So the best answer was going to be B. Solve for x on this one, if we introduce the square root, guys, it's only that the square root of 0, you cannot say plus or minus 0, guys. It's just a 0. So it was going to be x minus 4 equal to 0. So x is equal to 4. So there it was supposed to be x is equal to 4 or x is equal to 4 because a 0 cannot be written as plus or minus. So therefore, we just write a single value for x for that part. So that is our x is what? Of 4, which is the best answer was going to be A. Or you can just factorize. That's a difference of 2 squares, all right? Another way, just factorize a difference of 2, squared. There are 2 brackets, x minus 4, x minus 4. Not to say it's a difference of 2 squares, but there are 2 brackets equal to 0. So you just say x minus 4 is equal to 0, or this bracket, x minus 4 is equal to 0. So that's minus 4 to the other side was going to be a positive 4. Positive 4. So that's it. So that's our x is what is 4. Just like that on number 38. 39, 2 brackets equal to 0. All right. There are 2 brackets equal to 0 there. So just like the previous case, we can use that bracket concept. This must be equal to 0, x minus 3, or the bracket of what? 1 minus x must be equal to 0. Minus 3 to the other hand is going to be a positive. Minus x to the other hand so that it becomes a positive. So that's x is equal to 1. X is equal to 1 or 3. 1 and 3, 1 and 3 is on what? On C. So there, C was going to be the best answer. We are given that Mauritius buys cell phones for X rands each. This is the cost price, and then sells them to make a profit. There is a profit there, okay? He sells, or sorry, he determines his selling price, which is Y. So our selling price is what? Our selling price is Y. For each is each there, then here it's also each. So guys, there's no any adjustment there. So the question is that profit that he determined, it is being found by what? By doubling the price he paid. Double the price. What is the price? The cost price. So Y is equal to double that. If I have 3, double times 2. 4, double times 2. 9, double times 2. So if I have X and double it, X times 2. That's the double price. And it's another statement on its own. And then subtracting what? 3 rand from the double price, double the amount, is subtracted 3. Guys, it's a straightforward thing, isn't it? That was a straightforward. D was going to be the best. All right, that was our question 40. 41. We are given the perimeter of a square is given by, or is given as, that's as that expression, the way that we can have it. The same thing is given as 16 as a numerical value. So what is X? Guys, we are just writing the same thing in 2 different ways or 2 different manners. The one, it was under an algebraic expression. The one, it is a numerical value, but they do represent the same thing. Therefore, they are equal. It is the same perimeter that we are talking about, only written in different ways or different manners. So what is the value of X? Solve an equation. You can expand the brackets. You can choose to simply divide by the 4 as it is outside of the brackets. So X minus 1 is what? 16 divided by 4, that's a 4. Taking the minus 1 to the other side, or adding 1 to the other, to each side of the equation, our X was going to be 5. Minus 1 plus 1 eliminated. 4 plus 1, that's a 5. So X is 5, which is what? Which is on A. Question 42. Given this relationship, which ordered pair does not satisfy the equation? It is a trial and error. Already the equation is there. Try each and see which one does not satisfy. Which one? The X as our input, a point, an ordered pair is given as X versus Y, X, Y, X, Y, and so on. So you test the X values to determine the output, which are the Y values. So these are our X values. Let's test them. If our X is what? Is -2 on point on this A. Our X is -2. Put that and see if you are going to get the corresponding Y value, which is 3. Okay, let's put that. When X is what? -2. -2 squared minus 1. According to the rule that we are given. -2 squared, that is 4. So 4 minus 1 is what? Is 3. Exactly the Y value on that ordered pair. Guys, the pair is there. It consists of X and Y. For the X value, I have the Y value. Exactly the 3 that I have here. So this is correct. Move on to B. When our X is what? When our X is 0. test and put that and see. 0 squared minus 1. 0 squared, that is 0 minus 1, which is what? Minus 1. Is it what you have there as your y value? Exactly. Minus 1. Let's move on to see when our x is 1. Substitute that into the x there. 1 squared minus 1. 1 squared is 1 minus 1, that's a 0. Is it what we are given there? No, it does not correspond. It does not correspond. For the 0 that we could have obtained, it is giving us a 1. There is a 1 there. It is not what we're supposed to get. So it does not satisfy. We input 1 expecting to get a 0, but we are getting a 1. So that does not satisfy. Okay, let's consider the D condition and see if it does satisfy our equation. Y is equal to, for the x value, which is 2, 2 squared minus 1. So y is what? 2 squared, which is 4, minus 1, and that's 3. Is it the 3 that we are given there? So we can see exactly there is a 3. Exactly the y value. So it does satisfy what we are given there. So of all these points, guys, it was only C which does not. All right. So that is, guys, just a trial and error. You test the values that you're given on the answers, insert them into the equation and see which one gives the exact value or not. So according to these values, C was the one which does not correspond as an ordered pair. If you substitute the x value, it does not give the y value that is given there. All right, what are the values of x? Solve for x. Simple like that. X squared minus 3 minus 3x minus 18 equal to 0. Two brackets, as we've got a trinomial having the coefficient of x squared as 1. So we're going to have x and x. What are the factors of what? Negative 18. They must add up to negative 3. So many factors, negative 6 and 3, 6 and negative 3. There are so many, guys, that you can list. But for the sake of time, let us work with these two. Which one of these two, when we add, we must obtain negative 3. When we add negative 6 and 3, if we add this, we're going to get what? A negative 3. So that's negative 6, positive 3, equal to 0. Remember, it's an equation. Each bracket must be equal to 0. So therefore, x is equal to what? If we take or throw the minus 6 there, it will tend to be a positive. A positive 3, throw it there, it will tend to be a negative. So our x is positive 6 or a negative 3. So the best answer where there is these two was going to be where on B. Positive 6, negative 3. All right. So that's it. Just like that. So the best answer there was going to be on B. Number 44, an equation under our exponents. 2 to the exponent of m plus 0,5 is equal to 8 to the exponent of 0. This is 1. Any number to the exponent of 0, guys, is what? Is 1. So take the 0,5 there. It is going to be a minus, or simply subtract it. Subtract 0,5. So that was going to give us 0,5. Guys, 0,5 can be written as a fraction. Remember, 0,5. This is same as what? 1 over 2. 1 over 2. X to the exponent of negative n is 1 over x to the exponent of n. So rewrite this in the base of 2. It is same as what? 2 to the exponent of -1. Therefore, because the bases are the same, exponents must be equal. So m is 1. So the best answer was going to be on B, where our m is what? Where our m is -1. On question number 45, another equation, determine the values of x. In this equation, 6x over 3, why can't we just divide 3 and this? That's 2. So that's going to be 2x there. Right? 2x minus x is equal to 4x squared. 1 here. These are like terms, guys. So 2 minus 1, that's going to be 1x, which is same as x. Never be tempted to divide by x here, guys. It's a quadratic, remember. The exponent of 2 tells us that we must have what? 2 answers there. So what are you going to do? Take the x to the other side of the equation. So it's going to be 0 is equal to 4x squared minus, if we take it to the other side, it's going to be a negative there. So guys, remember a is equal to b, so therefore b is equal to a. So I can write starting with this. Why am I having x squared here? This is x. This is x, not x squared. Here to this, just x, not x squared. So I was saying, if a is equal to b, b is equal to a, remember? So this is equal to this. It is one and the same thing. I can even start with whatever that I want there so that I can properly factorize my left-hand side where x is common. I can factor it out. 4x squared divided by x. That's going to give us 4x. Minus x divided by x. It's going to give us -1. That's equal to 0. So guys, never divide by x, but you factor it out. You do not divide by it, you factor it out. From the 0 concept, each from the product must give us 0. A times b equal to 0. It's either a is equal to 0, b is equal to 0. So it's either x is equal to 0 or the bracket of 4x minus 1 is equal to 0. That's it. So here there is a solution. What about here? Let's solve. Subtract. So we add 1 both sides. So 4x is equal to 1. So divide by 4. We are done. Our x is going to be 1 over 4. These are the solutions: 0 and 1 over 4, 0 and positive 1 over 4, which is on what? On A. So the best answer was going to be A there. So you see, guys, it is mathematics, guys. It is about understanding the concept, understanding of the concept. Understand the concept, guys. It is understanding the concept. You can answer as many questions as you can as men. Just know the basics. The product of two consecutive even numbers, consecutive 2, 4, 6, following each other in that manner, consecutive, but they are even numbers. So if the first even number is n, because they follow each other 2, 4, 6, 8, what is the fact about these even numbers? There is a difference of 2 throughout. So if the first number is 2, I add 2, I'm going to get 4. 4 plus 2, 6, and so on and so on. 6 plus 2, 8. 8 plus 2, 10. So adding 2 to an even number, adding 2 to it, I obtain what? An even number again. So we are given 2 consecutive even numbers that we do not know. We do not know. So let the first one be n. And the second one will be what? N plus 2. Even number plus 2. So if the first even number is n, therefore the second one is going to be n plus 2. If the first one is n, the second one n plus 2. There's a difference of 2. for each consecutive what? Even numbers. So if the first is n, then the second will be n plus 2. So they say the product of these even numbers, because this one it's even, this one is also even again, but their product n times n plus 2, we are supposed to get 120. That's an equation formed. So determine the two numbers. What does it mean? Simply solve the equation. That's it. Solve that. You have formed an equation. From the statement given, you formed an equation. So then solve. It's just like that. Expand the brackets. N squared. N times 2, that's 2n, equal to 120. Taking the 120 to the other side of the equation, it was going to be negative 120. So that's it, guys. Let us factorize, as we have got a quadratic or a trinomial there, where there is n squared, its coefficient is 1. So I'm just going to put n and n here. So let's consider the factors of what? Negative 120. But they must add up to positive 2. So many factors of negative 120. But to get a negative 2, let's consider 12 and 10. 12 and 10. Negative, negative. Okay? Yeah. Let's do this way. Which one is going to give us a positive 2 when we add? These are the factors of negative 120, guys. If you multiply n of these, you're going to get negative 120. But when we add, where are we going to get a positive 2? That's here. If we add these two, we're going to get what? A positive 2. So that's positive 12, negative 10. So these are the numbers. Solve. N is equal to what? 12 to the other side of the equation was going to be negative 12. Negative 10 to the other side of the equation was going to be a positive 10. Remember the bracket concept, guys. I've explained this. So these are the numbers. So this is what I'm trying to say. Let's start with 10 so that you understand me, guys. If the first one, because we're saying the first one is n. Let's start with the positive. If the first number is 10, if it's an assumption. So we have assumed that the first number is 10, and truly it is an even number. So what's the consecutive one? The following, what is following there? The 10. N plus 2. The first, second, n plus 2. So 10 plus 2 is what? Is 12. So 10 and 12, those are consecutive. Follow each other. Positive. Okay, no problem. Let's talk about the minus 12 here, because there is a minus 12. Remember, they say the product, guys. We're talking about the product being positive 120. Remember, if you multiply a negative to a negative, you get what? You get a positive. So if I have a negative 20 as my number, what about the other one? If I add a 2 there, I'm going to get negative 10. So it can be minus 12 and minus 10. They can also work, both being negative. Minus 12 and 10. So given on our answers, they gave them as minus 10 and what? Minus 10 and 12. So means that this is what we want. 10 and 12, minus 10 and 12 is going to be the best answer of what we are given there. It's going to be the best answer. The product is 120. So if we multiply, guys, minus 12 times 10, you get positive 120. 10 times 12, you get positive 120. And they are consecutive even numbers. They follow each other in that. manner as even numbers, they follow each other. So the best answer was going to be on what? On C. That was question number 46. 47, given this table, what is the value of B? There is an input, there is an output. It was a type of a question where you can actually study it. You can see if I add like the difference between these 2 minus minus 1, there's a difference of 3. There's also a difference of 3 if you check. There's also a difference of 3. I saw this also on the output. There's a difference of 3 here. There's a difference of 3 here. 2 minus minus 1. There's a difference of 3. So there must be a difference of 3 between these two. Guys, are you seeing what I'm saying? There's a difference of 3 between this. So here there's supposed to be a difference of 3. So it's like 5 minus 3, which is 2. 2 minus 3 minus 1. So minus 1 minus 3 is what? That's our B. Minus 1 minus 3. So that's a negative 4. Guys, some of the questions, they are study like. You study the question, guys. Okay, you can use any proper way, but for 1 mark, if you can study and understand the concept, use as it is. What is the output value? Or if the input value is minus 5 on question number 48, there is a relationship already. The relationship is already there. They gave us a relationship. The input given as negative 5. What will be the output? Just substitute. So y is equal to negative 2 into x. The input in place of x, you simplify. So that's it. Negative, negative, that's going to be positive 10 minus 3. So y is 7. 7, the best answer, that's C. That's going to be C there. All right. 48, 49. What is the rule used in the flow diagram? Guys, just look into the answers and see which one is the best. Multiply by negative 2. Is it so? Negative 2. Negative 2 times this. We cannot get this. We cannot get this. We cannot. So negative 2. No, 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 no. This one is totally out. Negative 1. You multiply this. You cannot get this. It's totally out. By negative 6. If you multiply this, can you get this? Guys, this is totally out. What about negative 3? If we multiply this by negative 3, that is exactly what we see, positive 6. Multiply by negative 3, that's exactly what we have. Multiply this by negative 3. Guys, that's exactly what we have. So the best answer is D. Test. Test them. Just test them. You see which one corresponds. Those are the aspects of answering multiple choice question when it's like that, guys. Yes, some more guys, some of the things we just have to be okay. What is it that is happening here? You see, which graph represents the relationship between x and y in the table on question number 50? Which graph? Okay, graphs, linear functions, linear graphs. We talked about this, guys, and from our understanding, if I have a graph, a linear function, the important points on that graph are the intercepts, which is the x-intercept, the y-intercept, the x-intercept, the y-intercept. And what are the conditions for those two? The x-intercept, y is equal to 0. In the x-axis, where we have the x-intercept, x always 0. So look into the table if it is like that and see if there's a condition where x is 0, guys, it's there, here. So when x is 0 there, what is the value of y? X, it's 0. Y is what? It's 1. X is 0. Y is, that's 0, 1 as our y-intercept. Do we have a condition where y is 0 on this table? Is it there? Yes, it is there here. Y is 0. At that moment, what is the value of x there? X is minus 2. So minus 2, 0, it's a point. It's an x-intercept. It's an important point, a critical point. So there is x-intercept, which is minus 2. The y-intercept, which is 1. Look for those in these graphs that we are given. Look for those. Where x is what? Is minus 2 and y is 1. So the first one, y is minus 2. X is what? Is 2. Is totally out. Yeah, is totally out. B, our x is what on B? Our x is minus 2, which is what we have there. But the y value is minus 1, does not correspond. So B is totally out. The D, if we check, our x is positive 2. Is it what we want? No, our x is minus 2. So D is totally out again. Let's look into C. The x value is minus 2. What is it that we need? Minus 2. Y value, what is our y value? Our y value is 1. Exactly what we need. This is exactly what we want. All right, let's look into our diagram. If we check here, the y value, it's 1. X is minus 2, y is 1. Exactly what matches here. The x-intercept minus 2, the y-intercept is 1. So guys, look for those. The table, you look into the table where y is 0, that's your x-intercept. Where x is equal to 0, that's your y-intercept. So the best that describes that is what? Is C. So that was on our number 50. 51, what is the value of A? A being the input, and it is there also on the output. Guys, just insert it into the relationship there. When x is A minus 2 over 3A in place of x plus 1, we must get the output, which is minus 8a. It is an equation formed that you must solve for what? For a. Just like that. Just like that. Solve. So these are like terms a to the other side. That was 1 is equal to, if I take this to the other side, it was going to be minus 8a. This one is going to be plus 2 over 3a. It was a minus. The moment it crosses this equal sign, is going to be a positive. So let's simplify. Minus 8 plus 2 over 3, as they are like terms. A there. So minus 8 plus 2 over 3. All right? Minus 8 plus 2 over what? 2 over 3. So that was negative 22 over 3. Negative 22 over 3 times what? Times a. We need to solve for a. So it's either going to cross multiply, divide by, okay, it's up to you guys. You can do that. Cross multiply 3 and this, that's 3. 1 times negative 22, that's negative 22a. So divide by negative 22 both sides of your equation. So a was going to be negative 3 over 2. You can take the negative up. So that's negative 3 over 22, which is on what? Which is on D. So the best answer on this question was going to be on what? Was going to be on D. So questions can be like that. We can be given questions like that. Enter the input value as it is given to get the output, then you solve for that. Okay, so that is question 51. 52, okay, they gave us the point A here. Point A, this one, which is 3, x is 3. Remember the ordered pair 3, x versus y. So the x value corresponding to A and the y value. So it's 3 and what? -2. That's our point A, just analyzing it. So they are saying this point A, what happened to it? Is translated 1 unit to the left and 2 units up. 1 unit to the left, 1. And 2 units up, 2 units, 1, 2 going up. So when it moves 2 units going up, it will end up here. So this is where we have got its image point, which is A bar, the image of A at this point at 2 in the x-axis. That's the x-intercept. So it's 2, 0. That's our image. That's our image. I am just analyzing, guys. The A there moved 1 unit to the left, then 2 units, 1, 2. So it ended up here. Then they are saying these points, point A and its image, are joined to form a straight line. So we joined these 2 points, the one that was originally given and its image, the A and its image A bar, we joined them. And when we joined these two, a straight line definitely is what is formed. This is what they are saying. The A to its image A bar, they are joined to form what? To form a straight line. Exactly what we see. Which equation represents the straight line? By just looking into this question, it will be difficult to answer it because the straight line that we have just drawn here, it is due to the way the part that we have just drawn. It is not up to scale, guys. This line, if we check, it is. Let me remove it because it will confuse us. Let me get rid of that. The line. Let me reduce it to the y-intercept because this one is gonna give us confusion. This one. Let me just put it like this. Let me just join A to A bar, because if I extend it somehow, you might not draw a proper line. You might not draw a proper line, and would end up showing you other points which are not exactly the ones that you need. So just join like this because of that question that is being asked. Then okay, you work it from there. But if you join properly, guys, was it not gonna give us a proper line? Let me see, like this. It was not. It was not. It was supposed to be something like this. Yeah, it was supposed to be something like that. Let's see. Let's see. What can I do? All right. Let me redo this one. But I do not want you guys to apply this concept in exam. Because you see, some of you guys, when you are in exam, you'll be having different conditions, and that can actually affect you in your simplification. All right, it was supposed to be like this actually. If you draw it straight, it was gonna merge to a +4 there. But let's say it did not merge like properly, guys, according to your drawing. Do not worry. Because they said determine the equation. Use these 2 points on a straight line. They give us an equation, remember. So how do I find the equation? I'm just going to need the gradient concept. Remember, y is equal to mx plus c. M is the gradient, the change in y over the change in x. So meaning to say I'm going to have x1, y1, x2, y2. So from y2 minus y1, that's 0 minus minus 2. The y value is carrying a negative over what? X2, which is 2 minus our x1, which is 3. So that's our gradient, minus and minus, that's a plus. So 0 plus 2, which is 2 over 2 minus 3, which is minus 1. So it was going to be minus 2 is our gradient. Minus 2 is our gradient. Substitute this into m. Y is equal to minus 2x plus c. C is the y-intercept, which I can find by substituting any of these 2 points. So I can choose A or its image, which is the 2, 0. So I'm just gonna use the point 2, 0, guys. Yeah, because there is a 0 there. I want to take advantage of the 0 there. So xy, y is what? It's 0. And x is what? X is 2. So it's negative 2 times 2. X is 2. Okay, so that's it. 0 is equal to minus 2 times 2. That's negative 4 plus c. Taking the minus 4 to the other side, or add it both sides, it was going to be 4 is equal to c. So that's it. We can substitute our c there. So y is equal to minus 2x. C is what? 4. So that's plus 4. Plus 4. Okay. Okay. That is it. That is it there. So meaning to say, the best equation as of our answers, the best equation was going to be on B. Y is equal to minus 2x plus what? Minus 2x plus 4. So you see, guys, they will be asking these typical things, and you just have to be careful how the question is given, this and that. It'll be in your hands. You just have to understand, all right, if I'm given something like this, then I can evaluate it this way. Okay. Let's see the 53, question 53. From this equation, what is the y-intercept? Y is equal to mx plus c. It's 3 there, 0, 3. When x is 0, y is 3. This one was direct, isn't it, guys? 54. Let's see on 54. From this, what is the equation of f? This is our f. A line that is parallel to the x-axis. Remember, all these lines, y is equal to where the value of y is, that point where it crosses what? The y-axis, just like this one. Y is equal to 0. So what about this one? What is the y value there? 3. Y is equal to 3. The y value, minus 1, 3. It is throughout is the same, guys. So those are the lines of y is equal to this, y is equal to this, y is equal to 3 on B. So the best answer was going to be on what? On B, from what you're given. What is the gradient on 55? Y is equal to mx plus c. M is the gradient. So M is the gradient, the coefficient of x. So minus 3 over 2, which is what? Which is on D. So that is the best answer from what we are given. On question 56, this equation is represented, sorry, which equation? Which equation? They gave us points. So guys, it is just like the previous question. It's a point, minus 2 versus 0. It's a point. 0 versus minus 2. It's a point. And the best is that it is the y-intercept. So we just need the gradient, guys, and to know our y-intercept. So m, the change in y over the change in x. y2 minus y1, x2 minus x1. So that's it, x1, y1, x2, y2. So y2, that's minus 2 minus y1, which is 0, over what? x2, that's 0 minus x1, which is minus 2. So m is going to be minus 2 minus 0, which is minus 2, over minus minus, that's a plus. So it's going to be 2. So that's minus 1 as our gradient. Guys, y is equal to what? Mx plus c. So m minus 1 there, it was going to give us negative x. The y-intercept c is already there from the 0 minus 2. This is our y-intercept, remember. So it is what? Minus 2. Or you can substitute any point if you want. Still, you're going to get the same answer. You can substitute any point that you want. You are still going to obtain the same answer. So the best answer, which is giving us that equation, was on A. All right, that is A. On 57, this equation, what are the coordinates of the x and y-intercepts of the graph represented by the is equation? It does not change the way the equation is given. It does not change to say it is the x-intercept. The concept is still the same. For the x-intercept, y is supposed to be equal to 0. Does not change. So y, 0 there. You remain with 4x equal to 8. So what is the x value? Simply divide by 4. By 4, you solve for x. So x is what? Is 2. So our x-intercept is on a condition where x is 2. That's 2, 0. And the y-intercept, what are the conditions? Those conditions, they do not change. The conditions for the y-intercept, x is supposed to be equal to 0. So the whole part where you see x, it is a 0 here. So 4 times 0, guys, that's a 0. So you remain with what? 2y equal to 8. So if 2y is equal to 8, what is the value of y? Divide by 2 by 2. So y is 4. That's our y-intercept, where x is 0. Y is 4. So that's our y-intercept, 0, 4. X-intercept, y-intercept. So which one best describes these two answers of what we are given? 2, 0, and 0, 4. That was on D. On D here. This is the best, okay, according to what we're given. Then 58, the equation. The graph here represents this equation, y is equal to mx plus c. Okay, okay. What can be deduced from the graph? What is it they are comparing? The c, which is the y-intercept, m, which is the gradient. It's a comparison of the y-intercept and the gradient. First, guys, all these lines like this, they have what? Positive gradient, isn't it? The value of m is positive. So being positive on its own tells us that the value is greater than 0. Positive. There, it's greater than 0. The gradient. They are also comparing c, which is the y-intercept. If we check here, if we check, there is c, comparison of c, the y-intercept. So according to our graph, this is where our y-intercept is, where it crosses the y-axis, where it passes through the y-axis. Below the 0 there, below the origin going down, these are negative values. Our c, it can be -1, it can be -2, it can be -3, as long it's a negative value. So c is what? Is negative. A value which is negative is a value that is less than 0. So c is less than 0, where m is positive, greater than 0. Which one? C is less than 0, m greater than 0. C was the best answer to describe that condition. That condition was best described on that one. Number 59. What is the gradient of the line? All right, gradient of the line, you can just look for two visible points like this one. X is -2, y is what? Is 3. Here, it's a point. It's a visible point. X is 4, y is -1. It's a visible point that we can use. So you can use that. 4 minus 1, it's a point. Here, minus 2 versus what? Minus 2 versus 3. Use visible points where to a condition where you have to imagine to say, is this a 3? Is this a what? Visible points. You can also use this one. Here it's a visible point where x is 1 and y is 1. It's a visible point. Is it actually going to pass there through 1? Those ones are the ones that we can actually attest these ones, visible points. Find the gradient from there. Change in y over the change in x as before, y2 minus y1. So that's 3 minus 1 over what? x2 minus x1 minus 2 minus 4. So it was going to give us minus minus, that's a plus, 3 plus 1, which is 4, minus 2 minus 4 minus 6. So 4 over minus 6 is going to be 2 over 3, minus 2 over 3, minus 2 over 3, which is what? Which is D. D was going to be the best answer. D was going to be the best answer there, okay? Yeah, all right, that's it. Number 60, which graph represents the equation given here? Basically, just determine x-intercept and y-intercept and look into that. Our x-intercept, y is equal to 0, remember? So this cancels, so it's going to be minus 6x minus 4 is equal to 0. Minus 6x is equal to, you solve for x, so that's going to be positive 4 divided by negative 6, both sides. X will be 4 over minus 6. This is negative 6, remember? So it's going to be minus 2 over 3. Minus 2 over 3, which is something like minus 0, 666, and so on and so on and so on, which is less than 1. It's actually less than 1. Minus 0, minus 0,666, like that. Okay, that's our x-intercept. Minus 0,667. Okay, or like 67. Then the y-intercept, remember, y-intercept, when x is equal to 0, that's where we've got our y-intercept. When x is 0, when x is 0, it means this is 0, there's nothing here. So 2y minus 4 is equal to 0. Solve for y there. To the other side, that's a positive 4. Divide by what? By 2. Y is equal to 2. So 4 over 2, that's a 2, guys. So the y-intercept is on 2. Y-intercept is on 2. This one is totally out. All right. Y-intercept is on 2. This one is totally out. Let's move on to the x-intercept. The x-intercept is a negative 0,67, not a positive. So meaning to say A is also out. Does not correspond because our x is negative. All right. Where we have got y as 2 here, our x is it on the negative side. Yes, it is on the negative side. So this corresponds to the condition that we are expecting to have. Exactly what we are expecting to have. So that's it. Our answer there was going to be simply on what? On C. That is the best answer. All right, so that was the section A of our paper. Section A, guys, as you can see, it was actually, yeah, a lot of things to consider, which is fine. Then section B, question 61, simplify this completely. All right, so guys, here let us just expand our brackets and see what is happening here. X and x is going to be x squared, so it's minus 5 times 2, which is minus 10x squared. Minus 5 and minus 4, minus and minus, that's a positive, so it was going to be 20. X and x squared you add, so 1 plus 2, that's to the exponent of 3. Okay, this is x squared times 1, which is x squared. X squared and 16x is going to be 1 here plus, which is 3. So it's going to be 16x to the exponent of 3. Everything over the denominator, negative 3x. Remember, when it is like this, you must consider the like terms, same variable and exponent. To the exponent of 3, to the exponent of what? Of 3. So you add the coefficients there. 20 plus what? 16. That's 36. X to the exponent of 3. X squared on its own, there is x squared there. Minus 10x squared here and x squared. So minus 10 plus what? Plus 1. This one is what? A 1 here. So it's minus 10 plus 1, which is negative 9. So that's negative 9x squared over 3x. So each term can be divided by what? By 3x. Remember that condition, guys. Two terms separated by the denominator. So that's 36x to the exponent of 3 over 3x minus 9x squared over 3x. Guys, just divide here 3 into 36. There is negative, sorry, negative. So that's negative 3 here. So that's negative what? 12. X into x squared into x cubed. It's gonna be x. It's gonna be x squared. All right. So I need to divide this one. We said 12 there. You see this thing, guys, of now correcting. It's now affecting me here. Negative here. That's a positive. 3 into 9, that's a 3. So it's going to be positive 3. X into x squared, that's x. Okay, I think that makes sense. So this is it. You can even start with a positive 3x there and end up with minus 12x squared. It's still one and the same. You can obtain the 3 marks. All right, solve this equation. All right, solve the equation on question number 62. Just expand the brackets, guys. All right. Expand the brackets and see what is happening there. All right. Here, there are no brackets. Just rewrite as it is. 2x squared minus what? Minus 6x. Expanding the brackets here, we can see it is actually a difference of 2 squares, this one. A squared minus b squared, remember, is what? A minus b into a plus b. So here, x minus 3x plus 3, it was taken from what? X squared minus 3 squared, which is x squared minus 9. So it is equal to x squared minus 9, or you expand as usual. Still, you're going to get the same thing on your expansion. So doing this, guys, we can collect the like terms, x squared to x squared there. So that's 2x squared minus x squared minus 6x. The minus 9 crosses the equal sign, changes the sign to a plus. So that's equal to 0. As it is, they are like terms here. So this is 2 and 1. 2 minus 1, which is 1. So it's going to be x squared minus 6x plus 9 equal to 0. Okay? Factorize, as we have got a trinomial here. So we're going to factorize 2 brackets equal to 0. So that's x and x. Factors of 9, which adds up to negative 6. There is 3 and 3. But to get a negative times negative, it's positive 9. Negative 3 times negative 3, it's going to give you a positive 9. If you add negative 3 plus negative 3, you get a negative 6. So this is what we want. Minus 3 is equal to 0. This is the same as x minus 3 squared, guys, equal to 0. So remember, we talked about this type of equation, introducing of the square root. So x minus 3 is equal to what? 0. So x is equal to 3. If you take the 3 to the minus 3 to the other side, guys, this one, it was just a repetition later on. Yeah, for 3 marks. Okay, that's it. From this graph, determine the equation of the line. All right, simple. It is just like the previous one where we took points. If you still remember that one, where we had to take the points. You do the same thing. Look for points. There is a point which is complete. X minus 1 and y there is what? 2. It's a point. Minus 1 versus 2. X versus y. There is a point in the x here, guys. Guys, isn't this one just a repetition of that? It's a repetition, isn't it? This one is a repetition of the line, but it was they previously it was to determine the gradient. I still remember. Let's see. Let's see. It was to determine the gradient if we this one, yes. Is it? Or they're different now? Oh, 3 and minus. Okay, they just slightly, it was on the gradient. This time they want equation. So, guys, just a repetition again because you're gonna need what? The gradient first, then the equation. So that's question number 63. Let's find what? The equation. First, gradient. So you can say this is x1, y1, x2, y2. So first we're going to need gradient, y2 minus y1 over x2 minus x1. That's 0 on y2 minus 2 over what? x2, which is 3, minus our x1, which is minus 1. So at the end, our m was going to be 0 minus 2, which is minus 2 over what? A minus and a minus is going to give us a plus. So 3 plus 1, that's 4. Okay, reduce this one. It was going to give us minus 1 over 2 as our gradient. So y is equal to what? Mx plus c. Substitute that gradient, y is equal to our m minus 1 over 2. So that's minus 1 over 2x plus c. To find c, guys, substitute any of these 2 points, any one of your choice. But you can see that the best point, guys, where there's a 0 there, because you're not going to simplify a lot of things. There's a 0 already there for the what? For the y value. So if you take that one, it's going to be an advantage in your simplification. So I'm going to use that second point. I'm not saying if you use the first one, it's going to be wrong. No, but I'm just going to use the second one. It's easier because y, it's 0 there. So in place of y, put a 0, minus 1 over 2 times in place of x. What is our x? Our x is what? Is 3. So that's a 3 there. Then we can solve for what? We can solve for c. So that's 0 is equal to minus half times 3, which is minus 3 over 2 plus c. So the minus 3 over 2 to the other side is going to be a plus. So it'll be 3 over 2 is equal to c. Having the c and this part of our equation, guys, we can substitute there and find the final equation, which is y is equal to what? Minus 1 over 2x plus our c, which is positive what? 3 over 2. There is our equation as given. In that question, it was to determine the equation, guys. 3 over 2, you can also write this one as 1.5. In place of that 3 over 2, it is same as 1.5. Okay? Yeah, it can be like that. Gradient, then you determine the equation. Simple like that. On question number 64, given this, that there are blocks that are stacked in layers. These blocks, they are being stacked in what? In layers. There is one block in the first layer being stacked. So the first layer, one block. Each layer increases by the same number of blocks, each layer. So if I'm moving on to the second layer, I'm going to have this block, this one, it's 1. So I'm going to increase by 1 as it is. So we have to fix it, guys. They are in what? Stacked layers. So you're going to have this one on this other side, this one on the other side. Okay? So if we move on to the next, when I have these 3 as they are before, these 3, 1, 2, 3 as they were, then we just add these at the ends like that. So it was gonna continue, guys, like that, like that, like that, like that, like that. So the question is now, how many blocks are needed in total to stack 10 layers. It is about the layers and the total. If you check properly, the question is on the number of layers in what? In stack. And the blocks, how many, the total number of blocks. Total number of blocks. The question needs us to consider that part. Number of layers in a stack. To say one, says one. How many blocks do we have there? It's only one, which is true. But if we move on to the second layer, to the second one, this is the second, like 1, 2. This is the second one. How many blocks we have? We have to consider the total from the first one. 1, 2, 3, 4. There will be 4 blocks. So the third layer, the total, you must add everything from the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. And so on and so on. What type of a pattern is that? How is the output related to, say, you input 1, you get the output as 1. Your input is 2, your output is 4. Your input is 3, your output is 9. How are these numbers related from the input? For input is n, what will be the output? Guys, we can see this is 1 squared, 2 squared, 3 squared, 4 squared, and so on and so on. So if the input is n, the output will be n squared. Just like that. What is on the input has been squared. They are perfect squares on our output as a result of what? The squares of the input. So the question is, how many blocks, the total number of blocks is our output from 10 layers? Number of layers in stack. This is our input. So if our input is 10, our n is 10. What is our T10? Our output, 10 squared, which is 100. Mathematically, we can simplify in that manner. We can evaluate it in that manner. So that was the whole part of our question paper as we are to consider, guys, our GEC, guys. Okay. Some of the requests, guys, we do them out of will to say we are supposed to do this. Okay, anyways, let us prepare, guys, for our examinations. This is what we wanted. So, yeah, we just hope for the best for those who are going to utilize this. And we're going to try, if we have time, to also cover a typical paper 2 so that you can also figure out the issue here. The issue is knowing how questions are given as. It can happen, yes, they can repeat. You know, these guys from department, guys, they just repeat. Which is not what you must expect, guys, to say you must have everything as it is. No. Revision is for you to know how questions can be asked as and how to attempt them. It can be by coincidence that you find exact questions in your exam. If it is like that, it is your own advantage. It is to your revision. When it is like that, you're just revising. You saw them, you just answer them. Anyways, guys, that is what we had. We're going to look into paper 2 according to our time. We shall see if our time permits. But that is, guys, till we meet again.